Okay, welcome to example 4 in our graphs and functions topic. We've been looking at algebraic inverse functions, but we're going to have a look here at how to find it graphically. What we've been looking at for the algebraic inverse is that we're basically trying to swap around the x and y variables in our equation. So when we were trying to find the inverse of y equals 3x minus 2, we found that the inverse was going to be based around the idea of x equals 3y minus 2, because we want to swap the roles of the input and the output values to get us back to the beginning. So if we want to swap the x and y on a graph, then the way that we do that is we reflect the graph, or the curve or the function, in the line y equals x. So if you have a think about what that would mean, here the line y equals x is a very fixed line. It's a line with gradient 1 or 45 degrees that goes along like that. So if I were to take that line, I'll make it a dotted line. And if I were to take this straight line here, which I don't know the actual equation, y equals f of x, if I were to reflect it in the line y equals x, then what that does, if you think about what the general effect of that, if you've got the point 5, 2, and you reflect it in the line y equals x, we get the point 25. The y coordinate becomes the x coordinate, the x coordinate becomes the y coordinate. We're swapped around the roles of the x and y points. In other words, the inputs and the outputs swap places. So if we reflect this whole line in the line y equals x, then we end up with a graphical representation of the inverse function. So in this case here, remember how to do that. Any point that lies on the reflection line will stay the same. And what we're going to do is this point here, if you think about the distance from a point to the reflection line, it will be the same on the other side. Yeah, we could reflect on that. It would go about there. Anything that's on the y-axis here will be the same value along the x-axis, and so on, so that my line, if I choose to draw it, it will look something like that. It'll have to pass through the intersect point of the original line and the line y equals x, but it's going in reflection to that, so every point is going to be the same distance away from the reflection line. Okay, so this line here, if I write that down, is simply going to be written as y equals the inverse of x. Okay, inverse function of x. Let's try it with this second one here, y equals f of x. Looks like an exponential function of some sort, so I'm just going to nip this and nick this line that I've already drawn, just because I can, and it looks here as though it looks almost like a bit of a tangent, but it looks like it does cross over a little bit. So if I put my line here, then what I'm looking for is a line which reflects in the line y equals x. So I'm always going to write in what that line is. So here I've got y equals x. Always put it in your graph, which means that the reflection of that, if I take, there's a y coordinate there, a y-intercept, so there'll be an x-intercept about the same distance along. Any point that's kind of on the dotted line, now it's not a great diagram in the sense that it looks as though it's quite a thick line, so you know, there's almost a contact point there, and then it's going to go the opposite way. So we'll end up, of course, we're going to end up with something like a log curve. Just try and, it's kind of hard to do with a tablet, but we end up with a function. Let's redo the whole thing. I'll try and do it in one go. Yeah, something like that, that reflects in the line y equals x, and I can write down y equals the inverse. Now, of course, we don't know the algebraic form of that, and we could explore it or we could verify it using algebra, but graphically, that's how we get an idea of what the inverse is, and that's how you might have learnt what a log function looks like, for instance, because it's the inverse of an exponential function, and you can explore that graphically. Right, the last one here, we've got see if I can get this to come up. What looks like a cubic function here. So again, I'm just going to nick that line here. What's the inverse of that function going to look like? Well, there are a few contact points between the reflection line and the curve. I'm going to just add in my explanation as to what that line is. So that point's going to stay the same, so is that, and so is that, but it's going to go the opposite way, the reflection of it, if you understand. So that's going to go through there in that direction, and this one's going to go like that. And we're going to get a curve that looks something like that, y equals the inverse of x. Okay, so we can create an inverse function graphically by drawing in a line y equals x and then reflecting the original function in that line. Okay, hopefully that's helpful.